Hello everyone, I feel more alive for once. So I said it's time to make another video. Or I try to make a few, then just upload them, have them scheduled, or something like that now. Let's just move on to the next thing I want to show everybody. Alright, so here we have a circuit in front of us, obviously. Right? For those of us been following along with all these videos. And you might have remembered what these are from our other video, the JK flip-flop. If we take a look at the schematic, we see that we have a 5 volt here, a clock here, and the clock drives all of our JK flip-flops simultaneously, or in parallel. The only other thing we have is our outputs, and then of course we have some extra logic, these AND gates. And so our question then becomes, well, what happens when this circuit runs, or what this circuit really is? Well, if we had a 5 volt, if I run this simulation, we have 5 volts traveling into J and K. And so J and K are going to flip and flop, if you remember, every time the clock pulses. And so let's just see what happens when we run the circuit. Let's just slow the speed down a little bit. So that's high. Now this is high. Now this is high. And if you're tracking the binary, what these binary numbers mean in decimal, so you actually can see that what we're doing is we are incrementing through them all. And so this is basically what a counter is. That's what the circuit is. The big reveal, it's a counter, right? So our counter here just counts every time our clock frequency pulses. And this is an example of a synchronous counter because all the JK flip-flops are driven simultaneously in parallel. A asynchronous counter, I'll throw it on the screen here. Boom, look at that. The clock frequency, the clocks are driven not simultaneously, but based off of the output of the previous flip-flop. And so yeah, that's basically it. That's our counter. I almost revealed what it's going to be used for later. It's a very useful circuit. You'll see it all over the place. You can use it for lots of different things. Let's say, for an example, you want to track how many people enter your store, how many people, are walking through a turnstile. Well, you can use a microcontroller and track it on there and display it, blah, 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 right? Or, if you're a fan of finite state machines, you could just, make a little counter here, right? Our 4-bit counter here can only support up from 0 to 15, so 16 numbers total. So I don't know how well that'd work for a turnstile, right? Oh, we got 16 people. Time to, reset it. And so that's the synchronous counter. So I also made it from the component level once again. And so let us look at how it works at the component level. So currently we have it reset, because if you don't use the asynchronous reset, this whole circuit likes to have a heart attack. So let us drive the circuit. So you should see, if I speed up the simulation by a fair bit, that it's going to start counting through like our previous counter did. Right, and then this should be high, and this one should be high, high. And then it should be high, 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 and then our most significant bit will flip to high. And pretty cool stuff, right? It's going to work the same way the other one does, right? I mean, how would I mess it up? I have an example already on my screen above this, so. You can see it's the JK flip-flop once again, and you can see this is just toggling, once again, based off the clock, because when this, well, you can just track it, right? I could go through it, there's a lot on the screen, but, this goes high, this flips, it flips this gate, then obviously it's flipping back and forth between these two NAND gates, and then your SR, or RS, SR, whichever one you want to put first, latch here, and then it's flipping this output from Q and Q not. And then this travels into this AND gate, then this signal also travels from not just this AND gate here, but also drives the, oh god, I can't follow my own lines, the next JK flip-flop. And then this also drives the AND gate. And so this AND gate, once it has both 1 and 2, well, 1 plus 2 is 3, so once it goes from 3 to 4, it sends a signal down into our next JK flip-flop, has another AND gate, and then, obviously, it sends a signal down into our last JK flip-flop, and then this also sends its signals up over here for our output so we can see what's going on. And then I've tied all the asynchronous resets together so that we can reset the entire circuit at once, and you'll see that on any counter IC. You'll see that kind of same thing. You'll see an asynchronous reset. You'll see some inputs. You can actually let me pull up a schematic of one real quick, and you can see all the different pins, right? Asynchronous reset being one of them. You have some other ones for inputs, and then all your outputs, and all sorts of cool, crazy stuff, right? But yeah, so that's basically our synchronous counter. This is going to be very useful for something I show you later, and we're almost there. Actually, we've almost actually gotten to the very cool stuff, and that video will probably take a while. But I'll show you what you can do with all these things that we've been making. It's something that I made, and then I realized this is pretty cool stuff. And once you make something like that, you really can't forget about it.